Let's look at what's called the chain rule. The chain rule comes from the composition of two functions, and you might be remember this might jog your memory. It's this f composed with g stuff or g composed with f stuff. So basically, if you have a function f of x is I don't know, sine x, and then g of x is x plus 3 quantity squared, then f composed with g of x, you could write it as f with g plugged in, like this. So it's always the second one plugged into the first one. And so if you're going to write f, you're going to take this and you're going to plug it in wherever there's an x in the f equation. So this would be sine of x plus 3 quantity squared. So this was the algebra that you know and love from before. You could also do, you could also make something like, for example, you could say f of u is, let's say, x squared. I mean, sorry, u squared, and then g of x is, or sine x. So then f of g of x is, you plug sine x into that u squared, and you would get sine of x quantity squared, or just sine squared of x. So this is a composition of two functions. So now the question is, how do you take the derivative of this? Okay, and it's really not too bad if you just get the hang of it. So there's a couple ways to look at it. The first thing is to note that the derivative of f of g of x, the derivative of this is the derivative of the outside function, okay, outside function with g of x plugged in, times the derivative of the inside function. So the outside and the inside function, which ones are those? So the outside function will be this one here, and then the inside function will be this one here. All right, let's go back up here. The outside, because if you look, the outside function is this squared term here, right? And the inside function is, it's inside the parentheses. That's not always the case that it's so obvious, but it's kind of a good place to start when you're learning this. Here's another one, this other one that we had before. The outside function is the sine x piece, and the inside function is the x plus 3 quantity squared. So if you look at it in this context here, outside function, the sine part, and then the inside function, the x plus 3 quantity squared, like that. So it's the derivative of the outside function. So the derivative of the composition of function is the derivative of the outside function times the derivative of the inside function. So for the one that we had up here, sine of x plus 3 quantity squared, that one actually is going to be one that I don't want to do just yet. I want to show you a different one. Let me give you an example of this. So it could be something like x, let's say 2x plus 3 quantity to the third power. So there's two functions here. There's x cubed, and then there's 2x plus 3 inside of that. So this would be your f, and this would be your g. Plug g into f. Plugging this into that gives you all of this. So when we do the derivative with respect to x of 2x plus 3 quantity cubed, this will be the derivative of the outside one, so that's 3 times 2x plus 3 quantity squared, and then you take the derivative of the interior, which is just 2. Derivative of 2x plus 3 is just 2. And then you simplify it, so this would be 6 times 2x plus 3 quantity squared. And there's no reason to multiply all that out, you just leave it. I'll do another one. You could do one with sines, cosines. So let's say, let's find the derivative with respect to x of, let's say, sine of, let's say, tangent. sine of tangent of x. So the derivative of the outside function would be cosine. Derivative of sine is cosine. You plug in what you had before, that's tangent, and now you multiply times the derivative of the inside function, that's secant squared of x. And then I think I would just leave it like this: cosine of tangent of x times secant squared of x, and that's how I would leave it. Now the homework is going to have problems where they want you to split things up. What I've done is I've taken a lot of the homework from the book and I've pasted it here. So like we could do this first one. It says write the composite function in the form f of g of x and identify the inner and the outer. U is g of x and outer function is y is f of u. So the outer, so this is the cube root of, I'm looking at number 1, 1 plus 4x. So the outer function, I think, would be the cube root of x. So that would be f of u is cube root of u. And then the inner function would be g of x is, so yeah, g of x is 1 plus 4x. They call this u. U is 1 point. See, what's happening here is this. You have, there's another way you can look at it. You have a function of u, and then u is a function itself. So normally in algebra, you have, good old nice function of u, and you're done. But now, further in algebra, this guy right here, your little variable, is a function also. It's a function of x. So you have f of u, and then you have u of x. So another way to say this is f is some function of u, and then u is a function of x. All right, this might be a little theoretical for you. Hopefully not too much. It sometimes takes a while to get used to this. All right, so now that we've identified both those two functions, we can take the derivative. So the derivative of this, let's write it as a power to the 1/3 power. And so what we'll get, now we're going to take the derivative with respect to x. So the derivative of the outside is 1/3 times 1 plus 3x. 1/3 minus 1 is negative 2/3. And now you take the derivative of the inside, that's 3. If you notice, these two cancel. And so we get, let's see, yeah, 1 over 1 plus 3x to the 2/3 power. I'm running out of room here. And so that would be 1 over the cube root of 1 plus 3x. And we're done. That's the derivative. We can look at another one. All right, so I chose this one out of the book, y equals e to the square root of x. So what we can do here, there's no outside and inside, but there is a main function here, and that's y equal e to the x. So we're going to take the derivative. So let me just show you something real quick. So suppose u is some function of x. This is the way of saying u is a function of x. This is mathematical shorthand. Then the derivative with respect to x of e to the u, this is something you should memorize, is u prime times e to the u. This is the chain rule in action. It's basically, remember that the derivative of e to the x, so the derivative of e to the x is just e to the x. So the derivative of e to the u is just e to the u. But if that's if you're taking the derivative with respect to u. All right. If you're taking the derivative with respect to x, then you have to go ahead and keep going if u is a function of x. So the derivative with respect to x is e to the u times and then u prime. Or if you want, you can write u prime e to the u. So there's a way to look at the chain rule. So let's just finish this. And if you're not quite getting it, it may take a little while. let's take the derivative here. This is also known as e to the x to the 1/2 power, because that's the square root of x. So the derivative of this, the derivative is, it's going to be e to the x to the 1/2 power, and now you take the derivative of that x to the 1/2 power. It's 1/2 x to the negative 1/2, like that. So this is this e to the u times u prime that I wrote down here and here. All right, so now we would go ahead and simplify this out as, it looks like it's going to be e to the x to the 1/2 power over 2x to the 1/2 power. So that would be e to the square root of x over 2 square root of x. There's your answer. So there's a way to look at the chain rule that is also helpful, and it's the following. It says if f is some function of g, and g is some function of x. And I'll give you an example in a second. Let me just write down the theory. Then the derivative of f with respect to x is, all right, so f is in terms of g, and g is in terms of x. So in order for f to get to x, you have to go through g first. So it's the derivative of f with respect to g times the derivative of g with respect to x. There's a proof for this in the book. So see that. I'm not going to prove it here. But this is one way that the chain rule is a lot of times written. In fact, you should know this. So know this. Let me show you how this works in action. Let me give you an example of this. So if, let's say, f is a function of g. So it's, let's say square root of g. And then g is a function of x. So g is a function of x. So let's say that would be 2x minus 1. Then what we have when we do the composition is f of x is the square root of 2x minus 1. All right, now how do you take that derivative? So it's a composition of two functions. So then the derivative of f with respect to x is the derivative of f with respect to g times the derivative of g with respect to x. Notice that in a sense it looks like you can cancel these and then get this back. We are not canceling them. It's just that this is equivalent. These aren't true fractions in the sense of a fraction. So then to finish this up, we would take the derivative of f with respect to g. So that's from here. Square root of g is g to the 1/2 power. So that would be 1/2 g to the negative 1/2 power using the power rule. And then times the derivative of g with respect to x. That's from here. That would be a 2. So now this is, the 2's would cancel. And you end up getting just g to the negative 1/2, or 1 over g to the 1/2, or 1 over square root of g, which is then, g was 2x plus minus 1. So it's 1 over square root of 2x minus 1. So that's one way you can look at it. I need you to memorize this. All right. Now, let's do the same exact problem. So let's take this same exact problem and let's pull it down and do it differently. So I don't know if you can see that purple so well, so I'll do it in pink. So it's f of x is square root of 2x minus 1. This is also can be written as 2x minus 1 to the 1/2 power. So when you take the derivative of f, it's 1/2 times 2x minus 1 to the negative 1/2 power times the derivative of the inside, 2. The 2's cancel, and you get 1 over square root of 2x minus 1. Same thing as before. Same thing as before, right there. All right, so let me do a few more examples so that you can really get this down. So let's try this one here, but I'm going to modify it some. I want to do f of t is e to the 2t and then sine of 3t, like that, sine of 3t. So I'll just put the parentheses there. Now, let me walk you through, let's just walk through first this one here, okay? So let's just call that another function. Let's call it y equals sine of 3t. So this is the composition of two functions. It's not just sine of t, and it's not just 3t. It's one plugged into the other. So when you do this derivative, you have to take the derivative of the outside function and then multiply times the derivative of the inside function. So this becomes 3 cosine of 3t. Now, there is a rule here which it'd be nice if you knew, and it is this. The sine of u, when you take the derivative with respect to x, is u prime cosine of u. The derivative of cosine of u is u prime times negative sine of u. This is when u is some function of x, and then the prime means the derivative with respect to x. Let me see if you can notice a pattern here. Tangent of u, when I take the derivative. U prime secant squared of u. Secant of u, when I take the derivative. This is u prime secant u tangent of u. All right? So it'd be nice if you kind of memorize this pattern right here, just like we wrote down the one for e to the u. E to the u prime is u prime e to the u. You see how this works? So when we have this problem here, let me erase this piece here. This is a product rule. Let me call this capital F because I want to rename this capital F. Notice we have two functions here. We have little f times and then g of it. Little f and g, little g. So the derivative of this, so f prime of t will be f prime g plus f g prime. All right, so here we go. So f prime will be the derivative of this e to the 2t. So that'll be 2e to the 2t. I'm using this little formula right here. U prime e to the u. All right, so now I multiply times g. That's sine of 2t, sine of 3t. All righty. Plus, now it's f and then g prime. So that's e to the 2t, and then g prime is 3. We found that to be 3 cosine of 3t. And so what do we get here? Can we do anything with this? Yeah, e to the 2t, and then it's 2 sine of 3t plus 3 cosine of 3t. You don't need the parentheses really. And there we have it. Let's try another one. Try this one. So y prime is u prime e to the u. So this would give us 2x minus 1 times e to the u would just be e to the x squared minus x. And there you go. You just leave it like that. So that's a little start on how to do these.